Hi, it's Jellybean component time again. In two previous videos, we took a look at Jellybean Opamps and Jellybean voltage regulators and references. So I'll link those in if you haven't seen them. So this one is going to be Jellybean Comparators, and it's not going to be quite as easy. There's a few definite Jellybean comparators, but there's a few oddball ones as well, due to probably necessity. Anyway, let's get into it. A Jellybean component has several criteria. One is it has to have pretty much been around a long time to become the industry standard part, just the go-to part that you grab when, oh, I need a voltage regulator, I need an op amp, I need a comparator. Don't care too much about the specs. I just, that's the Jellybean one that you pick. And when a Jellybean component's been around for so long, often 30 or 40 years, then it's of course set the sort of like standard specifications. It's set the standard package, the standard pinout, and thing which most other manufacturers follow. And that's the thing about Jellybeans, is that they should be available from different manufacturers. Not only the big name ones, but also like the ones you've never heard of, all the Asian sourced manufacturers and everything else. If it's available from like 5 or 10 different manufacturers, including the no-namers, then you can be pretty sure it's Jellybeanish. Now, before we get to our first comparator, you might be saying, Dave, I don't even need a stinking comparator because I can just use one of my spare op amps that I've got lying around from my Jellybean op amps. I might have had a quad package or a dual package or something like this. I got one spare. I can just use an op amp as a comparator. Well, yeah, nah, as we say here in Australia, yeah, you can use it, but there are some traps. For young players, the main one being the speed of op amps. They're just not that fast. And you may think, what's the big deal? No worries, I'm feeding the op amp into a gate or something like that, a flip-flop. Well, let me show you the trap for young players. Let's take the LM358, one of our bog standard Jellybean op amps down here. Frequency response. Op amps are slow, at least the Jellybean ones are. So you look at the slew rate here, okay, 0.5 volts per microsecond. So if you want to swing from 0 to 5 volts, for example, like you would for like a 5 volt comparator, then you're talking 10 microseconds to do that. And not only that, because it's an op amp, it's not designed to be driven non-linearly like this and have the inputs and outputs slam like this. You've got another thing called the overload recovery time. I'm sure I've mentioned this in another video somewhere. There's another 10 microseconds just to recover, and then you got settling time and stuff. These things are as slow as a wet week. And not to mention other problems with, you might have diode clamping on the inputs, for example, of an op amp, which actually designed to protect the input. Well, that means they could have a limited differential voltage range on the input, and you can't like compare big voltage differences and stuff like that. You can come a gutser there very easily. Not to mention the basic fact that an op amp does not have an open collector output like a standard comparator will, as you'll see later. So you can't use them as window comparators to do your regular, OR-in function on the output and stuff. It's just, nah. It's not the right tool for your job. Yes, you can use, and I've used op amps as comparators because I had a spare op amp available, but yeah, you have to be very careful. But let me show you why the speed could be a problem. Input slew rate limitations on digital chips, which you might be feeding an output of a comparator into, for example. So I know we've started out on a complete tangent here, but it's pretty important. So let's go, like just a regular 74HC74 flip-flop, for example. It'll be similar for other digital logic. And here it is right here, input transition rise and fall rate. You're talking like 400-500 nanoseconds. So right there, your op amp is not fast enough to drive just a Jellybean 74, HC74 logic. So what does that mean? Well, if you've seen my previous digital logic tutorial videos and stuff, you'll know that flip-flops can get into a metastable state. Basically, any digital logic, be it discrete logic like this, it could be an FPGA, they're going to have a maximum input transition time unless they're a Schmitt trigger input, and a good majority of them aren't Schmitt trigger inputs. So you've got to be careful. If you exceed that maximum input rise and fall rate, then your gate can go into a metastable state and just go absolutely crazy, and you'll wonder why your circuits are going silly buggers. But anyway, enough of that. What is the Jellybean? It is and isn't the LM311. Sorry for all you 311 fanboys or 311 fanboys. It is the industry standard Jellybean component in that it's been around since September 1973. And yes, it is the industry standard, but it's probably not the go-to Jellybean component for a single op amp. If you just need one op amp in one package, you're probably not going to be using the 311 these days. I'll show you one shortly, but by definition, the Jellybean comparator is the LM311. Always has been. To a lot of people, always will be. As with all these Jellybean components, you should have them available in your CAD library, for example, in like different packages and things like that, and different suppliers in your bill of materials and supplier information and stuff like that. So you can just drag and drop these Jellybean components in. That's the whole point of these. Is you have them in your standardized component library. I need a comparator. I'm just going to drop in. I don't care about the specs. I'm just going to drop in a Jellybean part. But the problem with the LM311, it has some good points and it has some not so good points. The good points are that it actually has extra inputs, a balance and strobe input here, which we can talk about, and it also has what's called a float-in output here, or an uncommitted output. So this is what's called an open collector output, because there's nothing else internal. It's just got an output driver transistor like this, and the collector is not connected to anything. This allows you to do wire or configurations with your comparators. You can like tie all the outputs in parallel. You can get wire or wire and, depending on how you configure the inputs and stuff. And you can do logic functions with the output, and that's very useful. One of the main reasons why a good lot of, probably the majority of comparators are open collector comparators like this. But the LM311 is special in that the emitter here is not tied. It's like essentially floating, so that it's not tied through to your ground terminal like you'd get on a good majority of comparators out there. So the LM311 is still useful for that. If you needed an uncommitted output like this, or a floating output like this, yeah, the 311 would be your go-to thing. So what are the downsides of this? Well, unfortunately, it's only available in basically an 8-pin package. And most of the time when you want just one comparator like this, same with an op amp, you know, and you go in SMD and you want small, because you want to minimize your footprint, you'd want to go for like a 5-pin SOT package, for example, instead of this 8-pin SO one, because this has some extra balance and strobe, and the extra emitter output like this, they just can't fit the 311. You just can't get it in like a 5-pin SOT 23 package. So the 311 is not classified as a fast comparator, but 165 nanoseconds isn't too bad. It's not too shabby. Basically, we'll look at fast ones later, and they're an order of magnitude better than that. But, you know, it's you can get certainly a lot slower than this one. And then you've got the input bias and offset currents here, 300 nanoamps and 70 nanoamps. We'll look at low power ones later, and their orders of magnitude are better than this, down in like the picoamp region. But you know, this ain't too shabby for just, you know, and if you're not talking about like real high impedance applications, it's not too bad at all, and it can operate from a single 5-volt supply. But the good thing is this is one of the high voltage op amps we'll look at more later, and it can do basically plus minus 15 volts, so 30-volt supply, but it works happily at regular 5-volt. But this is by no means a low voltage comparator. We'll look at those later. And of course, it's got decent drive output capability, 50 volts at up to 50 milliamps drive. And this is one of the things with comparators, is that you have the big open collector driver, because you don't just want to drive digital logic, for example. You want to, in fact, one of the advantages of open collector like this is you might want to drive a relay coil. You might want to drive, you know, a solenoid, you know, even a real high current LED at, you know, tens of milliamps, something like that, or even a string. And the output voltage is capable of handling 50 volts, basically well above the rated supply voltage of the chip. Nice. And this is why you'll find like one of their applications here, white goods, for example. Like you might find these in, you know, washing machines and dishwashers that have solenoids and drive things and stuff like that. You might just use the good old LM311. So really the only reason you'd use the 311 these days is if, you know, you wanted like a 8-pin dip package, if you were doing through hole or something like that, it's just fine. You can get it in SO, or you wanted like a balance, for example, you wanted to make this a bit more precision, you wanted to put a pot in there and tweak it so that you can tweak the offset voltage, which is not that terrific in this. It's not that good because they don't tell you up the top in the banner specs. But it's not that bad. If you take a look over here, typically at plus minus 15 volts, you're talking, you know, a couple of millivolts, something like that. Could be as bad as 10 millivolts, for example, over the full temperature range. But you can actually put in a pot and trim that if you don't want to use like a real expensive precision op amp. But then you've got to pay for the pot, and then you've got to pay for someone's time to tweak it. And, you know, it's just like, it's really old school, like 1970s stuff. So here's an example of using the balance there with the pot and everything, and it's just, you know, like there's just better ways to do it these days. You just spend the money and, you know, get a more precision op amp if you need it. Anyway, the other function is the strobe, which is used as, shares a pin with the balance pin. And what this does, you need an external, you can't just strap it, you need like an external transistor here because this is a current driven thing, and it will actually disable the output. So it allows, you know, a micro or some other digital logic to actually disable the output transistor if you want to actually turn it off remotely, or you want to gate it or something, or strobe it as it's called. So once again, it's a pretty old school thing, more obscure application these days to have like a strobe capability on your op amp. But if you need it, hey, the LM311's for you. So what would be the go-to Jellybean single comparator these days? Well, you could argue probably the TS391. This is like an ST one, but there are many other manufacturers. This I'll show you in a minute. And it's available in a SOT23, some, you know, DFN 8 for those who, you know, DFN fanboys, but very similar to 311. It's got 2 volt to 36 volt capability, can be operated from plus minus 1 volt supplies to plus minus 18. So, you know, it's really quite schmick. It's got reasonably low current, 200 microamps, which is independent of the supply voltage, so it doesn't matter. So, you know, that's not too shabby, but this is not a low power op amp. We'll show you an option for that in a minute. 25 nanoamp input bias current, not too shabby. Input offset current, 5 nanoamps. Input offset voltage, plus minus 2 millivolts max. And once again, there are variations like A and B, you know, various versions. So this is the 391 and 391A, and this will vary between manufacturers. All these sorts of specs will actually slightly vary between manufacturers, in particular things like, you know, offset voltages and bias currents and, you know, stuff like that. So just be careful of that if you're doing a drop-in replacement. But as with all Jellybean components, if you're caring about, I do care about the difference between 2 millivolt offset and 5 millivolt offset, then, you know, on a card, I have to pick this manufacturer over that one, then you're not really in the Jellybean category. You just throw it in there, 2 millivolts, 5 millivolts offset, she'll be right, no worries. So the major specifications you're going to care about for a comparator are the input offset voltage, just like op amps. They have offset voltages, and if you're after really precision voltage comparisons, then this could matter, but you wouldn't be choosing a Jellybean for this. So, you know, input like typically 1 millivolt, you know, could be as bad as 9 over max temperature and stuff like that. And then you're going to have your input bias and offset currents, and this is pretty much due to the technology of the device. Is it a CMOS device, which we'll look at, or is it a bipolar device like this one? And you can tell because it uses, well, where's the internal diagram? There you go. It uses bipolar transistors there. None of that MOSFET rubbish. Then, of course, the other thing you care about is your supply current, your ICC here. This has got, you know, 200, 500 microamps, something like that. So it's not low power. We'll look at those in a minute, but, you know, good enough. I mean, once you start getting to a couple of milliamps, geez, that's a real high power jobby. Now, the input differential voltage, we might have a look at this later, but that matters because you can have like a real big, like 30 volt range comparator, yet it only has a small differential input voltage. So a bit of a trap for young players, that one, so that could be important. Just keep a watch out for it. Of course, the other biggie with comparators, because as I said, you usually want to drive relays or, you know, something grunty, LED, solenoids or something, is the output drive capability. This one, not that great, 16 milliamps typical. They don't actually give you an upper bound maximum on that. I don't know why ST aren't doing that. We might get it on another manufacturer, but yeah, I mean, you know, but that's good enough to drive like a relay or something. And the other biggie, of course, is the speed of the op amp. So the small signal response time here, 1.3 microseconds. But as we saw before, that might be too slow to actually drive like a digital logic, for example. So you've got to be careful. But because this is an open collector one here, then it's going to be dependent upon, that's a poor resistor, the external pull-up resistor you pull here for your positive go-in transition. That will depend on the capacitance of your line and the pull-up resistor value. But that's the same with all open collector comparators. So if you don't believe me that the 391 is available from different manufacturers, well, let's go over to LCSC here, which is like the Asian DigiKey kind of thing. 319 comparator, whack that in there, and we sort by price down here, and we get the TS391 from UTC, Unisonic Tech, and then we've got Rome. I'm not sure if that's a TSOP 5. I'm not sure if that's the same. High gain voltage comparator, I don't know, it looks similar, doesn't it? And then you've got the ST Micro one here, and then you've got the Texas Instruments, you've got an OnSemi one down here, you've got, the Rome one, the 2901, we won't go into that whole family, and then you've got TLV variants from Texas Instruments. There's another variant from OnSemi here, and, well, you start getting into lots of different variants, but you have to actually be careful here, because there's another trap. And here it is. Check this out, right? It's got 391 in the number here from Analog Devices, but it ain't the same. Look, 2.3 volts to 5 volt to 5.5 volt operation only. For example, the TLV 1391, which you might think, oh, it's got 391 in the number, it's the same. 2 volt to 7 volt open collector. It's not that high voltage range. So just be careful of that, and I'll show you another trap in a minute where the same thing applies. So just because it has the same digits in the number doesn't necessarily mean it's going to be an equivalent part. So yeah, you want to be careful. And after all that waffle, we finally get to the, what I think is the industry standard comparator out there, that Jellybean one that you're just going to use absolutely everywhere, which is the LM393. Once again, it dates from October 1979, old school. And as its name says, it is a dual comparator. So it's basically roughly equivalent to the 311, but it's available in the same SOA package, but you get 2 comparators for the price of one. And it's pretty much the one you want to drop in. If you don't use the other comparator, meh, doesn't matter. Just, tie it off or leave the pins uncommitted and just use the single one, and you might be able to hack it in later. One of the advantages of using a dual package. So it's got 38 volt voltage rating, input offset 370 microvolts, but yeah, you got to watch out for the spread of that. Input bias current 3.5 nanoamps. It draws 200 microamps, which isn't too shabby, so it's not super low power, but it's low-ish. It's got 1 microsecond response time. Once again, might not be fast enough for driving digital logic stuff and things like that, but it's for everything else. Yeah, it's good to go. And as I mentioned before, there are like this, 2903 series. So there are other manufacturers like series numbers in there as well. So they're basically an equivalent part, and I won't go into the details. It's just, same thing. Everyone just calls it the 393. How Jellybean is it, I hear you ask? Well, put in 393 comparator into LCSC, 116. Right, we sort by price here, and like down in like 3 cents per part, 3,700 in stock, 39,000 in stock, 210,000 in stock. Right, 173,000, no worries, right? And it comes from Hands chip, ones you've never heard of, HG Semi, Zalunda, ID chip, Diodes Incorporated, you've probably heard of those. EG Micro, never heard of, Who's 3 Peak, Onesie Zen 3, right? And then even you go up to massive 5 cents. You're into your OnSemi. Your real big brand names, your Diodes in Corp again, and Texas Instruments one is still down in 6, the 6 cents region for a genuine TI jobby, and they're just available from Pulop. You just got to see Pulop. Pulop, I think we've had those before, haven't we? I think we discovered them on a previous video, but yeah, right, it's all there. And just to prove there's no component shortage when it comes to Jellybean comparators, let's go to DigiKey here and search for LM393. And here we go. Look at this. 1.4 million in stock on the shelves at DigiKey. You got to pay, oh, look at this, almost 12 cents in 1,000 off quantity. You get a genuine on semi though, but you know, like serious stock, right? And this is just a DigiKey. No worries. And of course, it's the comparator of choice for vacuum robots. So here's this family comparison table, which I showed you before with the, you know, the 2903 and stuff like that, and the B version. And also, like, there's 193 and 293, which is available in same with the LM311 as well. And these are like just higher temperature range military components. You can see like minus 55 to 125 degree range, whereas your regular one here is like 0 to 70 degrees. But your B version, minus 40 to plus 85, for example. Some of these might have different ESD human body model ratings and stuff like that, and your offset voltages might be higher. The only reason they're higher is because they're rated over like bigger temperature ranges. So go to the OnSemi data sheet. It just shows like the packages better and stuff like that. It shows the internal connections better than the TI data sheet. And this is the industry standard pinout for a dual comparator. Of course, you lose the strobe and offset balance capabilities you get on the 311. But like if you're gonna, like, these are cheaper. These are often, the dual is often cheaper than the 311. So you're just going to throw in the dual anyway, because odds are if you're going to use one comparator, you might need another one. But of course, one of the big applications for comparators is a window comparator. So you need those two Opamps, and you need the open collector output like this, so that you can just, here it is here, the output is open collector, so that you can just tie the two pins together and you can all the outputs, and you can get make yourself a window comparator. Beauty. And if the dual job is not enough for you, well, you can get the classic 339 Quad comparator. Here it is, once again available in the 2901, the 239 and the 139 configurations. But it's basically both the 393 and the 339. I know they're a bit confusing, but they are basically dual and quad versions of the classic LM311. And once again, dates back to October 1979, old school. But the 339, it's everywhere. Jellybean has. The good thing about the 311, the 393, and the 339, I think I got that right, is that the common mode input voltage includes ground. So it can be 0, it can go right down to 0. So hence you can use these as single supply applications, and that's called ground sensing as well. So you can sense all the way, you can compare all the way down to ground. But the downside is these are not what's called rail-to-rail input op-amps. We'll show you those in a minute. So yeah, it can go down to 0 volts, but you notice that it has to be at least 1.5 volts below VCC. So you can't compare voltages right up to the supply voltage, the VCC voltage. So that's something to consider for these Jellybean ones. So let's now go have a look at what you might use for a lower power, lower voltage application. Now, if you're talking about low voltage comparators, window detectors, you know, just general low voltage sensing and comparison applications, then you might be looking at basically the same as the 311, but it's the LMV series. And you might remember this from our Opamps, which had a similar thing. Well, the same thing is available in comparators as well. So the LMV331 is the single comparator. The LMV393, it's the same as the 393. But you'll see how the difference is in a minute. It's the dual version, and then we've got the quad version, the 339, but it's LMV in front of it. V stands for voltage or low voltage. And it tells you right here, these are low voltage versions of the dual, quad, and single comparators, which operate from 5 to 30 volts before. Now they operate from 2.7 to 5.5 volts only. So only for your 3.3 volt and 5 volt TTL logic stuff. But that's a little long. It's everything these days, isn't it? When I was a boy. But you'll notice that this is still uses bipolar transistors mostly in here. There's one little sneaky bugger FET in there, but basically these are it's still a bipolar. It's not a CMOS comparator. Haven't gotten to those yet. And it's the same open collector output, no worries, but it's just designed for different voltage applications. So we'll have a look at the specs. So all of your parameters here, they're all quite similar to the just the LM version that we got before, but the difference is in its sensing capability, But the difference is, if you power it from 5 volts here, it does have a better input voltage range, but still not rail to rail. So it will be ground sensing. So the common mode input voltage range does go below ground, so that includes sensing to ground, but it'll still only go to 4.2 volts. So still not quite rail to rail input, but these are better suited if you know you're working at 3.3 or 5 volts. You know, drop this into your schematic instead of the regular 393, for example. But once again, be very careful with 331 in the number. LMV339. Well, this is TI, right? TI also make a TL331. It's very different. Yeah, it's like the 38 volt comparator again. It is not the low voltage jobby. So just be aware. Same number, but that prefix matters. Now, unfortunately, at this point, all the ones we've seen up until now, they are truly Jellybean Opamps. But here's where the wheels fall off the Jellybean billy cart, and pretty much you start getting into single source or maybe only like 2 sources or something like that. Now, all the ones we've looked at have been open collector ones, and they've had limitations in terms of like non-rail to rail inputs. They've had limitations in terms of speed and all sorts of stuff. So let's go and look at like a better class of comparator here. And let's go for the TLV370X family, so 3701, 3702, and the 3704. You can also get these second source. These are TI, but you can also get them second sourced from ST as well. They do the TS3021 and these are, you know, pretty decent ones. Even although I wouldn't call them Jellybean, these are kind of like the next step up in comparators for, you know, useful applications. As you can see here, these are nano power, so they're low power jobbies. They're push-pull outputs, so no more open collector outputs. It can both push the output voltage high, so it can actively drive it high. You don't need an external pull-up resistor to get the output. And of course, if you're driving relays and things like this, then this is not something that you'd be using. So they're available in single, dual, and quad versions. 560 nanoamps per channel, right? So none of this microamp rubbish, like nanoamps now per comparator. Input common road range exceeds the rails, so you can actually go to VCC plus 5 volts. So the input voltage range, you can actually sense higher input voltages than the rail, and the actual operational rails can go from 2.5 to 16 volts. So that's very useful. Use them for like 12 volt application. So even if you used it for a 12 volt application, you can still sense 5 volts above that. So up to 17 volts. Nice. So this is a push-pull CMOS output stage. So we've gone from our bipolar technology to our CMOS technology, just like you do in Opamps. This is the same for comparators, and there's probably hundreds of CMOS comparators out there, but I think, you know, these are good ones that you should have in your, you know, your parts library, so you can just drop them in. And the input offset voltage is nice on this, so you could almost call this like a precision comparator as well. 250 microvolts, of course, that's just typical. Like it could go up to 5 millivolts or 7 millivolts over the full temperature range and stuff like that. But it's fairly tight for your generic spec there. And now, because it's CMOS, your input offset and bias currents are down in the picoamps range. None of that nanoamp rubbish. 20 to 80, well, you could, you know, over the maximum temperature, but barely sneaking into the nanoamp range. But typically, like under 100 picoamps. Nice. So really good for like, you know, high impedance sensing applications. And of course, because it's rail-to-rail output now, it can actually drive directly to the VCC output rail. So it can go to within 80 millivolts of the VCC rail. Unfortunately, they're not perfect. They're not the fastest things around. So yeah, 7, ish microseconds, something like that. So if you need a really fast op amp, but that's the, you trade off power consumption with speed, of course. So these are literally nano power, right, for a reason. But yeah, like for low voltage, low power, like high input impedance applications that can go beyond a rail and stuff like that, these are just incredibly useful. Worth having in your component selection library. And you can see that the ST Semi has the internal diagram here, and yeah, it's like a mixture of bipolar and but FET input ones here, and of course the totem pole output there, or push-pull as it's called. None of this. If it just had like an open drain output, then it would just have this. If it says open drain instead of open collector, then you know it's a CMOS version instead of a bipolar version. But yeah, so it's a push-pull output stage. Now, the interesting thing to note, if we go into comparators over on LCSC, which of course lists all the major Asian manufacturers, they stock all of those. Now, if we actually search for anything, but you know, anything like really performance, like fast, for example. So let's go search for, okay, propagation delay. Let's search for, I would consider anything under probably 20 nanoseconds. Let's just go 50 nanoseconds, right? So let's go for a really fast comparator here, okay? And let's search and see what we get under 50 nanoseconds for a comparator. What do we got? TI, analog devices, Maxim, TI, these analog devices. Oh, 3 peak. We finally got one. We finally got one. There's no data sheet. Can't even look at it. But that is 12 nanoseconds. There you go. But basically, look, these are all name brand stuff. And the second page here, same. Analog devices, Maxim, you know, right? There's on Semi, right? There's basically, there's only that one manufacturer, Asian manufacturer, couldn't even get a data sheet for that makes a fast comparator under 50 nanoseconds. So there you go. If you want all this high performance stuff, and then if you want precision ones as well, then you start talking all your major manufacturers. The generic Asian ones that you haven't heard of before, they typically won't go into those sort of product areas. So that raises a question, why wouldn't they go into those areas? And this might be, it's not just comparators, it's other parts as well. You know, if you need, you know, if you open up like a cheap consumer thing and it's, you know, it needs some precision part for something, you're probably going to find one of the major manufacturers in there. You're not going to find one of the no-name Asian brands in there. If you've got any like really detailed info on why, leave it in the comments down below. But I suspect it's, you know, it's process variation, and they just, you know, can't control, or they don't want to try and control the you know, the processes to actually get, and all the testing requirements and everything else that goes into manufacturing really high precision, you know, high performance parts. They just generally don't seem to go into those sort of areas. It's really interesting. So if you wanted higher speed than these nano power type ones available, like the 3701, 370204, then take a look at the TS3021. Once again, I think this is only single sourced. Maybe you can get it somewhere else, but I can't readily find it. But anyway, this is, you know, a 38 nanosecond job here, and it's available. So if you only need one comparator, it needs to be reasonably fast, and you know, you need rail to rail, and you need low voltage and stuff like that, then this is, I would say this is probably one of the picks you'd go for. It's reasonably priced, does 38 nanoseconds, it only takes 73 microamps, rail-to-rail input, it's got your push-pull outputs, 1.8 to 5 volt operation, it's got a high ESD tolerance, and you know, it's not too shabby. Well worth checking out. And in terms of precision, you're talking input offset voltage, you know, like 500 microvolts, so that's not too bad. Once again, like over temperature, if you want to, you know, play the absolute specs game, then it, you know, could be as high as, you know, a couple of millivolts or something like that. But yeah, it's not too shabby. But here's where it counts. Rise and fall times over here, 8 and 9 nanoseconds. None of that microsecond rubbish. So, you know, these are pretty nice little fast, you know, low voltage comparator. I really quite like. And then you got your propagation delays and stuff like that. It's, you know, it's not too shabby at all. So well worth having in your parts selection. But if you want kind of, when you think about like a fast precision comparator, like old timers like me would think of the LT1016. That was, you know, it used to be like the go-to one. I don't know, leave it in the comments down below. They got a date on this? No, revision, no, they don't seem to have a date on this. But anyway, the 1016, it was like, at the time, was like the sort of like, you know, fast. It was the 10 nanosecond, ultra fast precision 10 nanosecond comparator. That says it all, right? So you would spec this thing in. It's not cheap. cheap. It's not Jellybean, and there's lots of other parts that beat it these days, you know, but it's sort of like a baseline where, so a lot of manufacturers will go, even in analog devices / LT will go, look, it's an improved version of the 1016. So it's ultra fast, you know, operates from a 5-volt supply. It's got low offset voltage, no minimum input slew rate requirements as well, so it's not going to latch up. It's pretty stable, you know, and output latch capability as well. So yeah, it's like lots of like precision-y type outputs, and it's got complementary outputs, so that's why it's in your 8-pin package, because it's got Q and not Q outputs as well. Thanks for playing. And a latch enable as well, so you can latch the output, so like sample and hold type stuff and things like that. It's really nice. Time to throw a curveball in, so we're definitely non-Jellybean now, and this is just a bonus one because I think it's really cute and it's fairly cheap too. It's like in the 25-cent category, and you can get it from 2 different sources. Very versatile part. It's the TSM102, and you can get it from TI and ST as well. So let's take a look inside here. So what do you get in this bad boy? Well, you get a dual op-amp, a dual comparator, and a voltage reference. Would you like steak knives with that? Anyway, yeah, check out this bad boy. So you've got 2 comparators in there, 2 op-amps, and an adjustable reference, all in the one chip. So yeah, you might have guessed what applications, you know, switch mode, power supplies, battery chargers, voltage and current sensing, over voltage, under voltage, window comparators, alarm detectors, sensors. So if you're doing all sorts of analogy stuff, you can actually combine. This is good part BOM consolidation. You know, if you need a Jellybean op-amp and a Jellybean comparator and a Jellybean reference, this will do it all in one, or it might do it. You know, you got to check your specifications. So they're relatively low power. The op-amps are 200 microamps a pop. The comparators are 200 microamps a pop, and the voltage reference, VREF, up to 36 volts. It's adjustable. It can sync from 1 milliamp to 100 milliamps, just like the Jellybean references we looked at last time. You know, 0.4% A grade. You can get standard grade versions. It's got latch up immunity. For the comparators, of course, which is what we care about here, input common mode includes ground, but this is not a rail-to-rail one. It's going to be open collector output, and you know, it's a 2.1 meg op-amp, and it's once again ground sensing, and a basically 3 to 30 volt operation here for both the op-amp and the comparators. So just, you know, similar to the other ones we've seen. So they've got separate specs for the op-amps, separate specs for the comparators, and you know, 1 millivolt input offset voltage, typical. They don't give you typical offset for the comparator, but you know, it's like in the same class as your 393s and your 311s and stuff like that, right? And your input offset currents, this is not, you know, it's down in the nanoamp region. You don't get a typical value there. You might get it over on the ST data sheet or something like that. And it's not got huge output current capability, just, you know, 16 milliamps typical. Doesn't give you like an upper one. Does it give you a maximum over here? No, it doesn't give you anything over here in the recommended operating conditions for the maximum. So, you know, but, you know, tens of milliamps, something like that, good enough to drive, you know, a relay or a decent LED or something like that. Yeah, unfortunately, ST's not going to tell you either. Yeah, it's like, it's practically, yeah, it's identical. They don't give you a maximum value for your sync current for your comparator, but yeah, you know, so yeah, it's got your reference, you know, your adjustable reference like this. Oh, application note, there you go, a battery charger using the TSM102. So, yeah, like TSM102, like there would be a voltage reference that you might use, and then, right, so you're using the internal voltage reference, hence the pin numbers there, 9, 8, and 13. You've got your adjustable output, you know, divider here to set your reference voltage, and then a series pass transistor in here to give you, right, a like a high current precision reference supply like that. So that's not too shabby. So they've got, you know, an application circuit for a battery charger here, for example, but you can use this thing for like all sorts of stuff. When you've got dual comparator, dual op-amp, and a adjustable shunt reference in there. So I reckon that's a very nice little bonus part there. Well worth having in your kit. Anyway, I hope you enjoyed the comparators. I know that's been long, and leave it in the comments down below. I know I left out your favorite comparator. Everyone will have their favorite. Oh, I use this little Dual CMOS jobby and it's the duck's guts. And yep, leave it in the comments down below. I know there's thousands of them. So yeah, just calm down, calm down. I know we haven't even scratched the surface of comparators. What, a 4,539, like, well, there'd be more Opamps, I guess, than there would be comparators. But yeah, anyway, yeah, there's just an absolute ton of them. So anyway, I hope you found that comparatively interesting. I'm here all week. If you did find it useful, give it a big thumbs up. As always, discuss down below, and please tell us your favorite. Like there's probably other Jellybean ones out there, but you know, the ones I covered were pretty much the Jellybean. But if you've got a good one that's available from like at least like 3 or 4 different manufacturers, for example, then that could be considered Jellybean, but also Jellybean in price and availability as well. Leave your favorite one down below. Catch you next time.